Dear students, welcome to my lecture. Myself, Dr. R. Arulprakasam, Associate Professor, Department of Mathematics, SRM Institute of Science and Technology, Katangulattur. Today lecture I am going to discuss Fourier series. It is Unit 5 in our syllabus. So first I will explain definition of Fourier series. Fourier series is nothing but the infinite trigonometric series. So a function can be expressed in the series representation in terms of sine and cosine. So the formal form series expansion f of x is equal to a naught by 2 plus summation n is equal to 1 to infinity a n cos n x plus summation n is equal to 1 to infinity b n sin n x, where a naught, a n and b n are coefficient of the series. The series representation is called Fourier series. Function defined in the interval 0 to 2 pi. Also, functions should satisfy the periodic function condition. So, how to find this coefficient value? So, by this integral formula, where the coefficient, a constant term a naught formula nothing but 1 by 2 pi integral 0 to 2 pi f of x dx. An, the coefficient an formula nothing but 1 by pi integral 0 to 2 pi f of x cos nx into dx. Bn coefficient, the coefficient Bn formula 1 by pi integral 0 to 2 pi f of x sin nx into dx. These three formula also called as Euler formula. So next one, any function I can express Fourier series expansion, it is possible. So it's not possible. So the given function should satisfy this condition. This is necessary condition for existence of Fourier series, the Dirichlet condition. What is the Dirichlet condition? Function is a periodic with the period 2 pi and bounded in the interval 0, 2 pi. Second condition is f of x is piecewise continuous with the finite number of discontinuity in the interval 0 to 2 pi. And third one is f of x has at most a finite number of maxima and minima in the interval 0, 2 pi. Following any given function f of x satisfies the following these three conditions means I can express in terms of the Fourier series representation, series expansion. So another definition one is important. What is convergence of the Fourier series? So I have three conditions. I have to choose one suitable point within the interval 0, 2 pi. Maybe the point is continuity or discontinuity of the function f of x. Suppose given chosen point, if alpha is point of continuity means the convergence of the Fourier series at a point x is equal to alpha is nothing but just to replace f of x to f of alpha. The chosen point alpha is interior point of the discontinuity of the function f of x. Then the sum of the Fourier series when x is equal to alpha is the average of the left hand side limit and the right hand side limit. What about third condition? Suppose our chosen point alpha is end point of the interval. So what is the sum of the Fourier is nothing but average of the endpoint value. This is following these definitions is very important. I explain what is the Fourier series expansion. When should exist the Fourier series expansion? The condition is called a Dirichlet condition. And third one is what is the convergence of the Fourier series? This is convergence of condition. These three definitions very important. And one more formula important. What is that formula? Already many times I explained this formula. The formula is integral formula is Bernoulli formula. What is that Bernoulli formula? Bernoulli formula. Integral u dv is nothing but ub minus u1 b dash plus u2 b double dash to come sometime up to this step. So Bernoulli formula, when should I use the Bernoulli formula? The Bernoulli formula, I have to choose a suitable u function. Thus, the successive derivative converts to 0 If then only I can use Bernoulli formula. Okay, I'll move on problem directly following these definitions, everything. So first simple function I can consider. So find the Fourier series. Find the Fourier series for the function f of x is equal to x in the interval 0, 2 pi. It is my first question. So how to find the Fourier series expansion? The formula name is called Bernoulli formula. The formula is very important. Okay. Find the Fourier series for the function f of x. I consider the simple function, simple trigonometric function, algebraic function in the interval 0, 2 pi. The problem is given. First, write your what is Fourier series representation. The Fourier series, simply I can write the Fourier series, always I can denote it by fs. The Fourier series for the function, general function f of x is equal to a naught by 2 plus summation n is equal to 1 to infinity a n cos nx plus summation n is equal to 1 to infinity b n sin nx. This formula for any given function f of x, I can express the Fourier series representation. This is the general formula. Then how to solve this problem? Given function is defined in the interval 0, 2 pi. That Dirichlet condition satisfied default. It is periodic function and discontinuity finite number of interval. It attains maximum and minimum. So the necessary conditions are satisfied. Here clearly mentioned find the Fourier series. That means what? It is defaultly understood that conditions should satisfy. So how can I express the series representation, Fourier series representation? So just I can find out the arbitrary constant value. So then how to find that arbitrary constant value? By using the Euler formula, that are Fourier coefficient formula. What is our Fourier coefficient formula? Where our A naught formula nothing but 1 by 2 pi 1 by pi integral 0 to 2 pi f of x into dx. By that integral formula, we are getting solution, coefficient value. So just simply substitute here 1 by pi integral 0 to 2 pi. What is given function? X into dx. You know the x integration value. X into dx nothing but x square by 2. Now substitute upper limit and lower limit. What is the answer I'm getting? 1 by pi. So 2 pi x, instead of x I can substitute 2 pi 4 pi square by 2, because 2x means 2 pi whole square, 2 square value 4, pi square value nothing but pi square minus lower limit value 0. Now I am simplifying this, pi cancel. So here cancel means I am getting 2 pi. It is for constant term value. And find your an coefficient value. What is the an coefficient formula? 1 by pi integral 0 to 2 pi f of x cos nx into dx. So here function defined, instead of f I can simply replace, give function value 1 by pi integral 0 to 2 pi f of x value x cos nx into dx. Here look at this, it is Bernoulli formula. What is the Bernoulli formula? Explain. U dv is nothing but ub minus u1 v dash plus u2 v double dash. It will go like this. Here u1 u2 is nothing but differentiation with respect to x. V dash v double dash is nothing but integration with respect to x. So how I can choose u function? The successive derivative converts to 0. This is the condition for choosing our u function. So here I am choosing, suppose I am choosing u function is cos nx, means what happened? Never to converge this to 0. So I can better choice. I can choose our u function is just x, just x. Just a minute, just x. Next, what about our dv function? Rest remaining other form is our dv. It is u dv. dv is nothing but cos nx into dx. What about the u1 value? U is nothing but differentiation value. U1 is nothing but x differentiation value 1. What about u2 value? 0. After that, all the derivative will be 0. We can stop up to u1. So what are the value you need? So just v dash. Here I have dv. Find your first v and then v1. So what about v? One time integrate with respect to d, we will get v value v. Cos nx integration value sin nx divided by n. What about v dash? Again, one more time integration with respect to x. So sin nx integration value minus cos nx divided by n. Already I have n, so I am getting n square. Can you understand up to this clear, right? Then what happens? Simply substitute the formula here 1 by pi by the Bernoulli formula u value x, v value sin just cos nx integration value sin nx divided by n uv by the formula minus x differentiation value 1 name, that integration value minus cos nx divided by n. Next term will be 0. Either we can do after getting u1 u2 v and v dash, substitute the formula. Otherwise directly we can proceed within this step. First find u and then v. After that, first differentiation value and then integration value. Proceed likewise, you get the integral solution 1 by pi. Now what is the upper limit and lower limit? Substitute upper limit. If I am substituting upper limit 2 pi, when I substitute x to 2 pi, it's a 2 pi. Sin any number of pi value 0, so I am getting 0. What about here? Minus minus plus, cos even number of pi value always 1. So what happened here? 1 by n. It is upper limit value minus lower limit value. What about lower limit? If I am substituting instead of x to 0, 0 into anything is 0. So minus minus plus, cos 0 value 1, 1 by n. So my answer is 1 by pi, 1 by n minus 1 by n. So answer is 0. So our an value 0. So next I'll move on bn value. What is our bn? It is coefficients. Sin nx coefficient value. Bn differential formula 1 by pi integral 0 to 2 pi f of x sin nx into dx. Look at this here, cos nx, here sin nx into dx. So we can use the Bernoulli formula, we'll get solution. So just I'm substituting here 1 by pi. So by the formula, it is just substitute function value. So integral 0 to 2 pi f of x value nothing but x sin nx into dx. So 1 by pi. Now I'm substitute directly using the Bernoulli formula. So it is u, it is dv function. So just write out u function value sin nx integration value minus cos nx divided by n. So by the formula minus, what is the next terms which will come? U v form, u differentiation value, v integration value, that's it. So x differentiation value 1 and v integration value cos nx integration value sin nx divided by n square, because already I have minus, that's why minus, already I have n, that's why n into n square. Now next term will be 0 by that differentiation value of 1, its constant differentiation value 0. So I can put 0 to 2 pi. Now substituting upper limit, what happened? 1 by pi, so 2 pi cos nx integration value. If I am substituting x to 2 pi, it is even number of pi value. Always I am getting 1 divided by n. Here minus minus plus sin any number of pi value 0. Upper limit is over, minus lower limit always 0. Now I can simplify, pi cancelled, minus 2 by n. It is for our bn. So I got all the coefficient value a naught, an and bn. So just substitute the coefficient value in the series representation, that is our Fourier series expansion for that given function in the interval 0, 2 pi. So f of x is equal to a naught by 2 plus summation n is equal to 1 to infinity an cos nx plus summation n is equal to 1 to infinity bn sin nx. It is general Fourier series representation where I know what is a naught value by the integral formula, Euler formula. I am getting a naught value 2 pi. So I am substituting here 2 pi by 2 plus what about an value here 0, the terms will be 0. So what about Bn value? Minus summation n is equal to 1 to infinity Bn value minus 2 by n sin nx. So I am simplifying these things. So 2 cancel. So I am getting pi minus 2 is constant, taking outside, summation n is equal to 1 to infinity. So sin nx divided by n. It is for given function Fourier series representation. This is the method to find this any function given for the Fourier series. Very simple. I will explain once again. Find the Fourier series for the function f of x equal to x in the interval 0, 2 pi means simply write first what is the Fourier series representation in the interval 0, 2 pi, and find the write your Euler coefficient formula. By the formula we are find your coefficient value. Where a naught is formula given, simply substitute the function, evaluate the integral, will get a naught value. Likewise, write the an coefficient formula and substitute the function using the Bernoulli formula. To evaluate this integral, I am getting an value. So here an value 0 and bn coefficient formula, just write out bn coefficient formula and substitute the function value in that integral and evaluate this integral, and we are getting the bn coefficient value. After getting all the coefficient value, just write to our Fourier series representation and substitute the coefficient value. Will formalize this answer of this problem. Likewise, the second question is to find the Fourier series for the function f of x is equal to x square in the interval 0, 2 pi. The same method, only the things function including x square. And suppose I am substituting f of x is equal to x cube in the interval 0, 2 pi. And third question. And fourth question, how to find the Fourier series for the function e to the power minus x in the interval 0, 2 pi. And fifth question, find the Fourier series for the function sin x in the interval 0, 2 pi. And sixth question, cos x in the interval 0, 2 pi. Try to the same method. Write your a naught formula, an formula, bn formula, then integrate, will get solution. Thank you, students. Next class we'll discuss remaining problem. Thank you.